Hello and welcome to this demonstration video of the OMEGA Digital Transducer Application. In this video, I will show you some of the most useful functions of the software. This free application supports all OMEGA high-speed USB transducers designated by the H suffix, such as PX409 USBH, PX51 USBH, and the LC411 USBH. It also supports the IN USBH, which connects any millivolt per volt load or pressured product to your computer, and our RS485 output transducer, the PX459-485. Lastly, it supports a variety of our temperature and relative humidity products, such as the TJ, IR, UTC, and RH-USB. The Digital Transducer application can be downloaded from the omega.com website by visiting the product page and clicking the software link. Once you have installed the program and connected your sensors, the Channels window is the first window that you'll see. The other windows, Configuration, Charting, and Logging, are accessible by clicking the tabs in the top left area. In addition, there are two drop-down menus, the Tools menu and the Help menu. The Tools menu provides some useful utilities such as configuring the serial ports, detecting sensors, etc. The comprehensive Help menu is quite extensive. It covers all the features in the four windows, gives in-depth walkthroughs covering logging, charting, etc., and includes a troubleshooting guide you can refer to if you have any issues. The Channels window allows you to view data from all your sensors on one screen. In the Channels window, you can see here that we have four sensors connected: the inline USB amplifier with a load cell, an OMEGA RS485 pressure transducer, an OMEGA USB pancake load cell, and an OMEGA USB pressure transducer. You can see how the digital readout changes when I press on the load cell attached to the IN USBH. The low and the high readouts record the max and min readings. The tare can be set and cleared by clicking in the bottom left corner and can also be controlled using the Settings Gear icon menu. The Gear menu can also reset high and low alarms. If I apply enough weight to trigger my 1.5 user alarm, I can reset it using the Gear menu. Alarms are enunciated in the Channels window only. We will cover how to set up alarms in the next section. The configuration window allows you to set parameters for your sensors. Now select the sensor you want to configure. I will select the IN USBH connected to a load cell. Now I can set items such as the channel title, the polling rate, in this case from 1000 per second to once per 30 minutes, the display update rate, and the engineering units. The engineering units change depending on the sensor type. I can set custom scalars and offsets to create my own engineering units. You can see that in the Channels window, I have 1 pound applied. I will click back to the Configuration window, set my custom scalar to 5, and enter the word Custom in the Custom Unit Name area. If I click back to the Channels window, you can see how the process value now reads 5 pounds, as well as showing the custom text. Note that the user alarm trigger has updated to the new scaling. Also in the Configuration window, I can set the decimal places displayed, and I can also apply 3 different filters. For the LC411 USBH unit only, there is a shunt setting allowing me to activate the built-in shunt calibration resistor. Note that I must press the Apply button for changes in the sensor configuration window to take effect. If I have an IN USBH attached, there is a special button that launches a wizard to field calibrate it with a millivolt per volt transducer, such as a load cell. If I have one or more RS485 device, such as the PX459-485, there is a wizard to configure that as well. We can also set user alarms in the area below. You can see the alarm I had set previously. I'm going to add an alarm and click the Enable button. I can choose a custom name and color if I want. I'm going to set the alarm to a high alarm and set the trigger to 2 pounds. Now, if we go to the channels screen and apply some force to my load cell, you can see my new alarm will enunciate once I reach my trigger value of 2 pounds. Notice that both alarms are enunciating because the displayed text is alternating between Alarm 1 and Alarm 2. Also, notice that since I had the latching checkbox checked in the configuration window, my Alarm 1 continues to enunciate even though I have dropped below 1.5 pounds. The charting window allows you to see real-time data from your sensors in a graphical view. In the channels area, we select the sensors we want to chart and press the Start button. You can see here that the data is displayed in the window in real time. I will apply some force to my load cell, and you can see that the y-axis will automatically scale. I will variably press on the load cell so you can see how the data is displaying on the chart. Now that we've accumulated some data, I'm going to press the Stop button and show some of the charting features. First, I will enable the Mark Points option so I can see each data point. I can use my scroll wheel to zoom in and out on data. Depending on where I hover, the zoom mode behaves differently. If I hover over the main screen, it zooms both axes, and if I hover over individual axes, it zooms just that axis. I can box zoom the data by pressing and holding the middle scroll wheel button. I can pan around my data by clicking and holding the right mouse button and dragging. Once I have zoomed into my data, I can view the value of each of the data points by holding down the left mouse button and moving around in the chart. If at any time I want to see all the captured data, I can click the Reset Axis button. Note that pressing this resets the x-axis to the setting in the x-axis area, in this case 10 seconds wide. Next, I'm going to show you how to use the windowing feature, so I will clear the previous data, check the cumulative box, and start charting. I will apply a load so that I have data on the chart. Notice that the window is displaying all the accumulated data on the screen. This is because I have the cumulative checkbox checked. If I uncheck it, the x-axis will have a fixed time value. The window size is currently set to 10 seconds, so you'll see that the window displays the most recent 10 seconds of data while saving the older data. If I change the window size to 1 minute, you can see that the window size changes accordingly. The window size is settable from 1 second to 30 minutes wide. I can toggle between cumulative and fixed window sizes. Note that if I zoom the x-axis, the data will stop scrolling. The data is still being collected, and I can click the Reset Axes text to begin scrolling again and see all my data. I can stop the graph and save it as a PNG file. Charting can be stopped and restarted repeatedly. Data is only deleted when pressing the Clear Data or Reset buttons or by closing the program. The y-axis area allows you to change the position and scaling of the y-axis and is useful if you have mixed engineering units. The channels area lets you control the color and engineering units of the data and set the real-time cap, which adjusts the maximum number of data points displayed on the chart during real-time charting. The logging window allows you to log the data from all your sensors. Here, we select the IN USBH and the LC411 USBH and press the Start button. In the Stats area, we can see how the samples are accumulating, as well as some other useful information. Once I have accumulated the amount of data I want, I can press the Stop button. You can see that the start time, stop time, and total number of readings are displayed on the right. I can export the data to CSV or Excel by clicking on one of the two buttons below. I will save as Excel. Once Excel automatically opens, you can also see the relevant data for the channel in the Excel header, including units, custom settings, start and stop times, sample counts, and the low and high process values. I can select my data and insert a chart. Note that it is often useful to start a logging session in conjunction with a charting session because the charting data cannot be saved or opened later. Thanks for watching this demonstration video of the OMEGA Digital Transducer Application, where I've highlighted the most commonly used features of the software. The simple, intuitive interface allows you to view, chart, and log your data from your connected sensors. In addition to the software, we provide a .NET API and a command set so you can easily write your own custom software. If you have further questions about our software or sensors, you can visit omega.com or contact us using the information shown on your screen. Thank you for watching.